All right, continuing on with the notes for Chapter 2, this time around talking about the microphone. Sound reproduction is affected by the mechanical and electronic means used within the mic to change the acoustic or motional energy of sound, a vibration of molecules in the air, to electrical energy. Kind of talking about the actual physical way that the microphone is working at this point. And there's a couple of different types of microphones that work in somewhat different ways. The first type we're going to talk about is the moving coil microphone. In the moving coil mic, electricity is formed by moving a conductor through a magnetic field. Then the diaphragm, which is a thin membrane, will vibrate as it is driven by the sound waves, and attached to the diaphragm is a coil that's also going to vibrate, and the vibration of the moving coil will cut through the magnetic lines of force produced by the magnets within the microphone. So the actual physical disturbance of air, which is how sound travels through the air, gets picked up by that conductor, which moves the diaphragm, which moves the coil. Then the electrical wave produced as a result of that will carry the imprint of the sound wave. Moving coil mics are sometimes referred to as dynamic microphones. They're very rugged and they provide high output before creating feedback, so that makes them really useful for live sound reproduction and for broadcasting. So that is the moving coil microphone. Next, we're going to talk about the ribbon mic. It's also known as a pressure gradient microphone, and this has a thin, usually corrugated metal ribbon suspended between the poles of a magnet. And you can see a graphical representation on your screen. The ribbon will vibrate in harmony with the sound waves. These mics were originally used in broadcasting quite a bit because they could be adjusted to pick up sounds directionally, which made it really nice in a studio setting, especially if you had many actors or many different elements that were creating sound, because back then, most of the time, sound effects were produced live. So this made the ribbon mic really nice to work with in that environment. But they were also very delicate, so it's very easy to damage a ribbon microphone. A condenser microphone operates through the use of an electrical element called a capacitor. Why we call it a condenser mic? Well, capacitor is the new name for what used to be called a condenser, so the name kind of stuck. But that's the basics of how this works. Let's get into a little more detail. The capacitor stores an electrical charge that applies voltage to the diaphragm and to the backplate of the mic. The relative change in voltage between these items reflects both the frequency and the amplitude of the sound reproduced. Condenser microphones often needed a separate power supply in order for them to really be effective. That separate power supply will place a charge on the back plate of the mic. So if you ever hear the term phantom power, this is what is generally going to be used to help the condenser mic be able to do what it needs to do. A lot of audio boards will have phantom power provided within the board to be able to work those microphones. Sometimes, depending on the situation, you might be using something like a direct box to help to give power to a microphone or a pickup device, and that's what they do. They provide that extra power that is needed. The fourth type of microphone, we don't deal with these a whole lot in broadcasting. Piezoelectric microphones, also called crystal mics. They take advantage of the ability of some minerals that can be made to convert sound vibrations into electrical signals. Those of you that use acoustic guitars, for example, and there's an electric pickup inside your acoustic guitar. If it doesn't use a battery to help power things, it may have a piezoelectric mic in there to help amplify the sound when you play that guitar. Now, so we've talked about the different types of mics. Now we're going to talk about the pickup patterns of microphones. And there's a few ways that microphones actually hear sound, what sources they will actually listen to. First off is an omnidirectional mic. An omnidirectional mic will pick up sounds equally well from all sides. Now, here on the screen, you have a couple of graphical representations of what an omnidirectional mic will do. This graphic over here on the left shows what would happen if you are standing right here and talking into the microphone. So the mic will pick you up here. It'll pick you up if you're on the side. It'll pick you up fairly well if you're kind of talking from behind the head of the microphone. So this is an omnidirectional microphone. This graph over here shows basically the way that pickup patterns are represented graphically when you're looking into the features of a microphone. Say if you're cruising a website or checking out literature about a microphone, that is a graphical representation here on the right side of how they would show the pickup pattern of the mic. And it's showing it as if you were basically standing on top of the microphone, speaking right into the very tip of it. So omnidirectional picks up equally well from all sides. The bi-directional microphone accepts sounds from the front and the rear, but it rejects sound coming from the side. So you see that here as well. Sometimes the bi-directional mic called a figure of 8 mic because of the way that the pickup pattern works here. You can talk into the front of it, you can talk behind it, but anything from the sides is going to be canceled out. Then you have the cardioid microphone. These are sometimes called heart-shaped microphones. So if you've ever done a cardio workout, they deal with trying to get your heart healthy and pumping. Cardioid, heart-shaped. So you can think of it that way. It's also called a unidirectional mic or a directional mic, but cardioid mics will pick up sound from only one direction. You see that representation there on the graph. There's also different types of cardioid microphones called supercardioid and hypercardioid. They'll have a tighter curve in the front, but they'll also have a little bit of a lobe in the back. Supercardioid and hypercardioid microphones are great if you really want to isolate the sound that the microphone picks up. If you're looking for it to only get information from directly in front of the mic itself and not pick up anything from the sides. Let's talk about the frequency response of microphones. And there's basically two components that we're concerned with when we talk about frequency response. First one is range. Range simply means the amount of the frequency spectrum a mic can hear. Take a look at your textbook. You will see a chart of frequency response, the way that it's represented when we look at what a mic can pick up. When you look at this chart, the straighter the line, the better the microphone reproduces a particular frequency. If there is very little difference in the way the microphone picks up high, middle, and low frequencies, if the line's fairly straight the whole way across the graph, it'll provide a balanced sound quality. And this characteristic of the response curve is known as its shape. So that's the second component that we look at. We look at range and we look at shape. Now, the shape of a microphone and the way that it modifies certain frequencies adds to the coloration of the sound. Think of coloration as kind of the connotation of the way that you hear something, if you will. It basically gives a certain quality to the sound, a certain timbre. Some mics will offer a presence boost feature that can add even more intelligibility to voice by varying the response shape of the mic. Often, recording engineers miking music setups will want a mic with a flat response, a mic that is capable of responding equally well to all frequencies in the whole audio spectrum. This allows the engineer to be able to use mics in a more universal sort of way and to give them multi-purpose at times, especially if you have a limited number of microphones. A mic that responds equally well to all frequencies, it's said to be high in fidelity. Think of fidelity and you can think of it in terms of accuracy. It's basically how true or how faithful the microphone picks up the actual sound that you hear and how close the result of that is. So one way to think about this is if you've ever heard of in a married couple, if someone has committed infidelity, they were not faithful to their original spouse. Same sort of idea here. How faithful is the mic in picking up the original sound and trying to keep the integrity of that original sound? That's what we're talking about when we're talking about fidelity. Cardioid microphones tend to boost bass frequencies, that's the lower end, as the sound source moves closer to the mic, and this is known as the proximity effect. Some announcers that want that deeper sound, what they'll do is they'll move in very close to the mic with a cardioid pickup pattern, and as they do so, the microphone does a lot better at picking up those lower sounds from the announcer and creates this intimacy that results in the way that the sound is picked up and the sound is carried overall. There is a side effect though. Because you're dealing with more of those lower range pitches, it can affect intelligibility because the sound gets a little muddier and it can sound like somebody is mumbling or just not come across very clear. So the proximity effect is a great tool to help someone get that bassier sort of sound, but it has to be used with a certain amount of caution. It's better to have a microphone that is really good in the frequency response of those lower hertz ranges to make the proximity effect really effective. And with that, we'll take another break. We'll finish up the chapter with part C of chapter 2.